Hello. In our previous lesson, we introduced a system of rules for natural deduction in sentential logic. There, we discussed both elimination and introduction rules for conjunction and disjunction, so we are done with those connectives. Although we talked about the rule of conditional elimination, we are not done with the horseshoe yet. Where is the rule of conditional introduction, you may be asking? Well, this rule is a bit more complicated than the other ones we've seen, so I thought we should devote a separate video to it. So, how would you go about justifying a statement of the form, if X, then Y? One everyday and not so everyday way is through hypothetical reasoning, or the making of assumptions. So, in keeping with our example from our last video, suppose that you're convinced that if you go on vacation this summer, you'll get sick. How would you arrive at such a conclusion? You might go into hypothetical mode. Here, you start by making an assumption, which might or might not be true, but which you're accepting for the time being. That assumption is made against a backdrop of beliefs about reality, which are the background for your reasoning. Then, when you make a hypothesis, you carve yourself a little niche in logical space. You start to consider alternative scenarios in which something you're interested in is true. In this case, you consider a scenario in which you do go on vacation, and then, in your mind, you go through the consequences of that assumption. So, what happens if you go on vacation? At this point, you might be starting your inner dialogue with an if, and then you'll be working your way towards the then part. Well, you know that given your particular and real circumstances, which I won't mention here, you only have two possible destinations, Canada and the Amazon rainforest. Now you explore each of the possibilities in turn. What happens if you go to Canada? Here you consider a hypothesis within a hypothesis, if you will. Suppose that you read on the news that there are some nasty wildfires raging on in Canada, and you know that if you go there, you'll be breathing fumes and particulates, which will become lodged in your lungs. As a result, you'll inevitably get sick with some dangerous lung disease. So you reach the sub-conclusion that if you go to Canada, you'll definitely get sick. Okay. Now you consider the other sub-scenario. What happens if you go to the Amazon? Well, you know that there's a lot of mosquitoes there that carry malaria and yellow fever, as well as many other bugs that carry other infectious diseases. Also, you know that, for some reason, you're a real magnet for bug bites. So you know that if you go down there, you'll definitely get bitten by a bug. And given your stress levels these days, your immune level won't be able to handle it. And so, again, inevitably, you'll fall ill. So you turn the page and conclude that if you go to the Amazon, you'll get sick. But you know that you only have two possible vacation destinations, Canada and the Amazon, and in each of them, you expect to get sick. Thus, no matter where you go, you'll get sick. So this mental experiment started with the assumption that you'd go on vacation, and you ended up with the result that, in that scenario, you would surely end up with some illness or another. Thus, based on your scenario-based reasoning, you come back to reality with the conclusion that if you go on vacation, then you'll get sick. In sentential logic, we use a somewhat similar procedure to introduce conditional sentences into a derivation. But instead of talking about hypothetical scenarios, we use a device called the subderivation. More about this in a second. Suppose that our task is to show the validity of the argument that has this conditional sentence as its conclusion, and this other sentence as its premise. This is analogous to the if-then statement that was the outcome of your reasoning about hypothetical vacation scenarios. Whereas the premise is comparable to those antecedent constraints you have to consider, like the constraint that you only have two possible destinations, or your belief that the Amazon contains malaria-transmitting mosquitoes. So we start our SL argument as always, by stating our premises. We keep our conclusion in a corner to remind us of where we want to arrive. Since we want to show that if A is the case, then C is the case, we start by introducing A as an assumption. The assumption we begin from always corresponds to the antecedent of the conditional we aim to prove. This opens a subderivation, which starts on line 2. A subderivation, as you might have guessed, is a derivation that occurs within another derivation. This other derivation is called the outer derivation, So our premise in line 1 occurs in the outer derivation, whereas our assumption in line 2 is part of the subderivation. The purpose of our subderivation is to prove the consequent of the conditional we want to introduce, which in this case is C. So our goal here is to prove C. Our next step in the subderivation is to write A or B by means of disjunction introduction from line 2. In a later lesson, I'll discuss some strategies for constructing derivations, and we'll see why we might want to take certain steps at a particular stage of the proof as opposed to certain others. But for now, I'm only trying to show what subderivations look like, so just follow along without worrying too much about the whys and whens. Okay, clearly we obtained A or B, so we could detach the consequent in 1. Now in our system, if we are in the middle of a subderivation and we need to use a sentence that occurs in the outer derivation, we have to bring that sentence down to the subderivation. We do that by means of the reiteration rule, which simply allows us to copy the sentence on line 4. The reason for this apparently unnecessary step is that a subderivation must be self-contained. A subderivation is, after all, a derivation, so every sentence in a subderivation D must be either an assumption or the result of the application of valid rules of inference on previous sentences in D. If we simply wrote on line 4 the result of applying conditional elimination in 1, we would have a sentence that is neither an assumption nor the exclusive result of previous sentences in the subderivation, and thus the step would be, strictly speaking, illicit. Hence, we have to rewrite sentence 1 on line 4. But once we do that, we can keep all our proceedings nice and cozy inside our subderivation, so we get C and not D by conditional elimination from 3 and 4. And by conjunction elimination in 5, we get 6. But by doing so, we have reached the consequent we wanted to derive, so we've reached our destination. Then we discharge the assumption. We started with the assumption that A and arrived at C as a subconclusion. So we don't need our assumption anymore. In consequence, we discharge the assumption and close the subderivation. On the next line, we write A horseshoe C, the conditional we got from our subderivation. And then we write the rule that justifies this step, which is conditional introduction, abbreviated as horseshoe I. We also cite the lines, but instead of writing 1 or 2 lines separated by a comma, as in our previous rules, we cite a range of lines, 2 through 6 in this case, which are the lines occupied by our subderivation. Okay, I hope this has given you a taste of how subderivations work. Now, let's take a closer look at the rule of conditional introduction itself. Here's a concise statement of the rule. If y is the conclusion of a subderivation having x as its assumption, infer x horseshoe y. Here we can see it in the form of a diagram. At a given line m in a derivation, we open a subderivation by making an assumption, which can in principle be any sentence x. Then, from previous steps in the subderivation, we arrive at a given sentence y. Having reached our goal, we close the subderivation, and on the next line, we write a conditional that has the initial assumption as the antecedent, and the last sentence in the subderivation as its consequent. Then you cite the conditional introduction rule, followed by the lines comprising the subderivation. That is, the range that starts with the line in which you wrote the assumption and ends with the last line before closing. As we noted earlier, we now have a reiteration rule, abbreviated as R, which we use so as to keep subderivations self-contained. This rule can be stated thus. If a sentence occurs, either as a premise or as a conclusion in a derivation, the sentence may be copied, that is, reiterated, in any of the derivation's lower subderivations, or lower down in the same derivation. This is a good point to illustrate the situations in which sentences can and cannot be shifted around. At the beginning, we have an initial derivation. Inside this, we can have a subderivation. And inside that subderivation, like Russian dolls, we can insert another subderivation, and another one, and so forth. For ease of exposition, let's label each of these subderivations with a number, such that the larger the number, the more deeply embedded the derivation. So suppose that we have a sentence X in derivation N. Then we can use reiteration to bring that sentence into a derivation that is nested inside the previous one. In other words, we can push sentences in. But now suppose that we have a subderivation embedded inside another derivation. What we can't do is take that sentence and use it outside of the closed subderivation. And so, it is with subderivations as it is with Vegas. What happens in your subderivation stays inside your subderivation. The reason for this is clear. When you were imagining what happens if you go to the Amazon, one of your subconclusions was that in that fictional scenario, you were sick due to a mosquito bite. Now, you can't take that fictitious event out of your hypothetical scenario and then insert it into your real life to get an extension in your exam because, well, your hypothetical scenario and real life are two different things. We also introduced another structural element called scope lines. These are the vertical lines that separate a subderivation from an outer derivation, or from another subderivation that contains it. In sum, we have our general derivation. Inside our derivation, we can have a self-contained subderivation. The outer derivation contains the premises, as well as the conclusion we extract from our subderivation by an application of the conditional introduction rule. Every subderivation starts with an assumption. If we are planning on using conditional introduction, the assumption will be identical to the antecedent of the conditional we want to prove. And the conclusion of the subderivation is the consequent of the same conditional. Once we have reached the consequent of the conditional, we close our subderivation to further inspection. Then we take the conditional out of the subderivation and then rewrite it on the next line, citing the horseshoe introduction rule and the relevant lines. Okay, let's do an exercise. Show that this argument is valid. We begin with our premise. We also note that the conditional we want to prove has A as its antecedent. So, we open a subderivation and add the sentence A as our assumption. Some people write assumption or simply A to the side by way of justification. You can do that if you want, but you don't have to. Now, the consequent of the conditional we need to prove is A and B, or A ampersand B. So that's what we are aiming for. We want the last line of our subderivation to be the sentence A ampersand B. But first, let's take care of the preliminaries. We need to bring if A then B into our subderivation with the aid of the reiteration rule. To be honest, this rule is kind of annoying, so I promise that in future lessons we'll take this reiteration step as a given and we'll skip the redundant writing. But for now, let's do the extra work that is required by the definition of a subderivation. Our next step is to detach the antecedent from 3 with the aid of 2, so we get B. But notice that we needed to form the conjunction A and B, and we already have both of these sentences occurring separately in lines 2 and 4, respectively. So we simply join them together in line 5. And so we have reached our goal. We started with the assumption that A and ended up with A and B. So we have shown that if A, then A and B, given our premise, of course. So we close our subderivation and write the conditional in the next line. And we add the justification, which is horseshoe I, on lines 2 through 5. Now, let's show the validity of this other argument. What is important about this conclusion is that although the main connective of the sentence is itself a conditional, the consequent is also conditional in form. So we have embedded conditionals. How are we going to deal with this? You'll see in a second. We begin by writing down our premise and by keeping in mind the conditional we need to prove. The antecedent of the target conditional is A, so that's our assumption. Our goal then is to prove if B then C, but this sentence is also a conditional. And we know that to prove a conditional, we simply assume the antecedent and then work our way towards the consequent. And that's exactly what we're going to do now. So we'll add a new subderivation embedded in the first one, and the assumption is the antecedent of the new conditional. Notice that the consequent of the relevant conditional is now C. So our subgoal will be to derive C. Then we import the premise and the assumption from the first subderivation. and we join A and B. Then, since our conjunction in 6 matches the antecedent of the conditional in 4, we can detach the consequent from the conditional. And so we get C in 6 by horseshoe elimination from lines 4 and 5. But C was our sub-goal, since it's the consequent of the embedded conditional. So we closed the subderivation. We started with B and ended up with C. So we write if B, then C on the next line together with the justification, which mentioned the lines of our second subderivation, going from 3 to 7. But then in line A, we also reach our general goal, which was to derive if B, then C. So we close our first subderivation and write the appropriate justification. Let's do, as a final exercise, a derivation for this argument. As always, we start with our premises, and we can see that the antecedent of our target conditional is itself a complex sentence, not A and B. And that's exactly what we write as our assumption. Remember that our assumption is whatever sentence is the antecedent of our target conditional, regardless of what kind of sentence it is. Our goal is now to prove F or G. We then do the reiterations to be able to exploit the premises. Extract not A from 3 and get D from 4 and 6. Then we get F by conditional elimination from 5 and 7. And then we form F or G from F by disjunction introduction. And so we have reached our goal. We close our subderivation. We write the conditional that has our assumption as its antecedent and the last line of our subderivation as its consequent. And we write the relevant justification. Okay, in this lesson we started by noting a gap in our inventory of rules, which we filled by including the rule of conditional introduction. But we are not done yet, since we have discussed neither the biconditional nor negation rules. So in our next lesson, we'll introduce 2 rules that govern the negation symbol. Okay, that's all for this video. Bye!